When clients' web servers use Hypertext Transfer Protocol, or HTTP, to transmit information over the internet, the data is transmitted using plaintext format. Using plaintext format can be a risk for web traffic security because anyone can view plaintext data that travels over HTTP. Now, to protect the data confidentiality, SSL, or the Secure Socket Layer, an application level protocol, encrypts network traffic such as your HTTP traffic. E-commerce sites also use SSL as the default protocol to protect data from theft and exposure. SSL encrypts the data between the web client and the web server. The identity of the web server is validated because the web server provides its certificate as a form of authentication. Different types of applications can use SSL, but in most cases the client application is the web browser. The authentication process begins with the web browser establishes an SSL connection to the web server. This connection is established when the user connects to the URL that begins with HTTPS, or Hypertext Transfer Protocol, over SSL. Upon connection, the web server then sends its certificate to the web browser. The web browser then examines the certificates and confirms that the certificate has been signed by a certificate authority, or CA, that changed to a trusted CA, that has not been tampered with, and that has been issued for the purpose of server authentication. In addition, the web browser also checks the certificate is still valid and has not expired. And that name of the server certificate matches the name of the website, and that the certificate is not part of a list of certificates that the client explicitly does not trust. If the web browser has certificate revocation checking enabled, it checks the CA certificate revocation list, or CRIL. If the client computer does not have a cached copy of the CRIL, or if the cached CRIL has expired, the web browser retrieves an updated CRIL from the CRIL distribution point specified in the certificate. If the certificate fails any of these tests, the web browser prompts the user to proceed. If there are problems with the certificate, the web browser extracts the web server's public key from the certificate. The web browser can use this public key to send it to the web server. The process of sending encrypted data from the web server to the web client begins when the web browser creates a pre-master secret, which is a randomly created string of bits. The length of this string is based on a negotiation between the web client and the web server. The web browser encrypts the pre-master secret with its web server public key and sends it to the web server. The web server uses its private key to decrypt the pre-master secret. At this point, both the web browser and the web server possesses the pre-master secret. The web server and the web client use the pre-master secret to create a session key. The session key is a symmetric key, which is used only for the current SSL session. Because both the web browser and the web server use the same algorithm, both sides create the same session key. Because both the web browser and the web server possess a symmetric session key, both sides can encrypt and decrypt the data. This process ensures message confidentiality and message integrity. The user can be assured that the data cannot be viewed or altered by someone who intercepts the data. Internet Explorer explains a lock icon whenever uses SSL connection with the web server. Now, double-clicking this icon displays information about the certificate and allows the user to validate the certificate chain. When the HTTP session is closed either by the client or the server, the session key is discarded and not used again. When the web client establishes a new HTTP session with the server that uses SSL, the process is repeated from the beginning. You have just seen how clients and servers use, in this case, SSL channel to transfer information.